Good afternoon and welcome to APA's weekly webinar series co-sponsored by the Center for Campus Fire Safety, CCFF. My name is Billy Zadek, Standards and Codes Administrator for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to APA's webpage later this afternoon. You'll receive a follow-up email in the next couple of days with a link to the webpage where all webinar recordings are housed, as well as a link to our upcoming webinars. We have webinars planned out through December 2020 and are open for registration. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by our presenter. Professional continuing education credits, AIACLUs, and ICC recertification credits are being offered. For AIA certificates, please send an email to Billy, B-I-L-L-I-E, @APA.org with your membership number. For ICC CEUs, if you are a CCFF member, please email Kathy Tabor at ctabor@campusfiresafety.org for your certificate. At this time, it's my pleasure to turn this over to Kathy Tabor, who will tell you a little about CCFF and introduce our presenter today. Kathy, take it away.
Thanks, Billy. Hi, everyone. I am Kathy Tabor, the Executive Director for CCFS. I want to start by thanking you all for joining us today and also to thank our presenter, Denise Pappas. CCFS is a national, nonprofit, member-based organization. We've been dedicated to campus fire safety since our beginnings in 1999. We're governed by a 12-person board of directors located nationwide. The majority of our board are fire marshals on college campuses, fire safety educators and inspectors, and then some of our other board members are internationally known industry leaders. I guess I like to say that we're fortunate to have a leadership team made up of well-known and nationally recognized leaders in the area of campus fire safety. And we're here to help anyone that has questions or needs help. Some of our activities include training programs for campus fire safety officials and emergency responders. We have premier events such as our annual Campus Fire Forum, which unfortunately this year has been canceled, but we will hold it again in 2021, and the information is on our website, so take a look. Excuse me, as a member-based organization, the benefits we offer are free webinars to members, CEUs, discounts for training, an online job board, a listserv, and a lot of networking opportunities, a library of free online resources, and a monthly e-magazine. Membership is only $50 per year for college and university, so just check us out at myccfs.org. It's a new website, and for those of you that don't know that much about us. Excuse me, Paul. Now at this point, I'd like to welcome our presenter, Denise Pappas. Denise is the Executive Director at Caltrain Corp. And serves as technical standards for Valcom. She brings us extensive experience in telecommunications and fire alarm industry. Denise participates in a variety of code committees, including NFPA 72, Emergency Communication Systems, NFPA 101 and 5000, the Life Safety Code, and Intelligent Building Systems. And she works on several International Code Council committees. Denise is the Communications and Systems Chair for the NEMA 3SB team as well. So at this point, it's my pleasure to turn it over to you, Denise.
Thank you, Kathy. Welcome, everyone. I know there's lots of things you could be doing today, but so glad you decided to join us. Realizing there is more than one way to achieve our goal of monitoring fire alarms, we are going to include all modern communication signaling technologies today. So let's get started. Here is an agenda of the items we will be covering. As I know your time is valuable, I will try my best to keep this presentation to around 45 minutes max and allow time to answer your questions. We've got lots of things to cover in a short amount of time, so let's get going. When we talk about emerging technologies, we need to first understand a little bit of history about legacy communications in fire alarm management. It was historically done by direct wire, you know, where they had to lay trenches and bury the wires between buildings. Can you imagine how much it would cost to trench a 300 building campus? Or maybe you can. Or sending coded signals, you know, where there was an alarm code that came in as, say, code number 7, and you would have to reference a chart to see what that code means. I have a customer that has this type of system today with over 500 codes. Can you imagine how long it would take to look up a code you were unfamiliar with and the exorbitant amount of time it would take to figure out what that code meant if you were really unfamiliar with that code? Or the distributed multiplex systems that were a step above these, but still relied on hard wiring schemes. How about the telephone wires? If you think about the legacy equipment, it reminds me of our home phone with the cord on it. You could only go as far as the phone cord would allow you. Growing up, I was one of 8 children with one phone, and we had a party line at that too. Oh, for those of you that might not know what a party line was, imagine if you picked up your phone and you overheard a conversation your neighbor was having with someone. You would politely ask, how much longer do you think you're going to be on this phone? Because I need to make a phone call. Then we moved to the cordless phones at home, and you could roam around the house or even go outside if you were within range. I'll never forget when we got our first cordless phone. I could sneak off to a tiny closet and talk to my friends without being discovered until I started laughing. I got busted every time by my brother, who always seemed to have an emergency call. Those were the good old days. Now with today's technologies, we can go almost anywhere with our mobile phones and continue talking on them. It's hard to imagine that the first iPhone was introduced 13 years ago on June 27, 2007, and some people said they weren't going to invest because they couldn't see the average person spending $500 or more on a phone, and they laughed at the idea. Well, who's laughing now? The fire and life safety industry has been going through transitions as well. When we talk about emerging technologies, we are talking about anything that causes a disruption to the status quo. Now, instead of being tied to the legacy communications technologies, much like that old home phone, newer technologies like IP Ethernet, radio, and cellular are remaking the industry, much like the iPhones, in ways we could only have imagined a few short years ago. Take a moment and think about your particular campus facilities. Oftentimes, you are faced with the very real challenge of how to upgrade your communications signaling technologies while keeping your current fire alarm control panels functioning and maintaining cost control. A tall order, even under the best of circumstances, when, say, there's not a pandemic going on around you. Most importantly, protecting lives and property is mission critical to you. Incidents at organizations with life safety responsibilities or at-risk property can result in high costs and public relations nightmares. Like those home phones, the old copper plants, distributed multiplex, or coded signal systems are going by the wayside, and newer technologies are taking their place on today's campuses. The new signaling communications technology that is right for your campus will depend on your specific needs. Things that come into play are considerations of construction for installation. Does it make sense to use existing wire or to maybe go wireless? Do you have available personnel for testing and programming of these systems? Can you train existing personnel to do the testing and programming? Now one of my favorites is who is going to take ownership of the communications network and available networks? Will your facilities department have their own IT expert to handle and maintain your systems, or will the IT department want control? I've actually seen both scenarios, and each works well for their respective campuses. Are there other reasons you are going to upgrade? Most campuses make the decision to upgrade when they are expanding, remodeling, or adding new buildings to their existing campuses. Or perhaps you may want your system to be code compliant to reduce liabilities. Or existing legacy signaling communications technologies are failing on a regular basis, and you need to upgrade to a newer, more reliable, faster, and more flexible signaling technology scheme. Or you are blessed and you finally have the money and the budget for the upgrades. Before we get much further into this presentation, let's first take a quick look at the typical fire alarm management process. The main part of the alarm management process involves the signaling communications, the monitoring, dispatch, and reporting system. But how does the whole process start? Well, first you're going to have an initiating device, whether it's a pull station or a smoke detector, and these are typically activated either manually or automatically, and they signal the control panel. The fire alarm control panels receive that information and activate notification devices, speakers, strobe lights, etc., via NAC circuits and outputs. Then various communication technologies, whether it's IP, wireless radio, cellular, telephone lines, or direct wire, transmits this information to a monitoring and dispatching center. It is here that the speed and reliability of the system is critical to achieving fast, accurate response. Newer signaling technology communication solutions improve the transmission of signals from devices and alarm systems into a single comprehensive alarm management system for optimal response and situational awareness. After all, a fire doubles in size every 30 to 60 seconds. Why is that important? Because building materials today are more flammable with a faster flashover rate than 20 years ago. So quick response is crucial to saving lives and property. Think about it this way. Do you remember some of the first computers when you were sitting at home and you heard that noise and you waited and waited to get connected? You know what I'm talking about. Now think about it in today's terms. We turn on our computer and we are instantaneously connected. This analogy is similar to the difference in time it takes for our computers to come up today. I was on the phone with AT&T talking about a cellular connection, and I wanted to know, how long did it take for a signal to take information from a transceiver, go through their secure IPsec tunnel APN to the AT&T data center, back to the campus router to the front end to report the alarm? Exactly 438 milliseconds. That's less time than it took me to say 438 milliseconds. Since we're talking about speed and technologies, I thought I would share about how fast 5G is. If you were as naive as I was at one time, you may have thought that moving from 3G to 4G was just a factor of 1. And then when you moved from 4G to 5G, you improved your speed by a factor of 1. Let me tell you, that is really not the case. This illustration shows you the speed of all three in a very interesting way. So imagine if you wanted to download the 2-hour-long movie, Guardians of the Galaxy. Great movie, by the way. Now, since I am a super multitasker, I like to download the information and do something else at the same time. So what could I do in 3G if I was actually downloading Guardians of the Galaxy? Well, I could fly from New York to Sydney, Australia. That would include check-in times for a total of 26 hours, an entire day plus 2 additional hours. Wow, that's a lot of time. Now in 4G mode, you can take that same movie, Guardian of the Galaxy, 2-hour movie, and while I'm downloading that, I could run a quick 6-minute mile. For anybody that knows me, you know that that's totally not me. I can't run that fast. I can't even walk that fast, I don't think. But in 6 minutes, I might be able to check in on my Snapchat, my LinkedIn, or my other social media to pass a few minutes. But now here's where the real speed comes in. That same 2-hour movie, moving from 4G to 5G, downloads in 3.6 seconds. So we're going from 3G, 26 hours, 4G, 6 minutes, and 5G at 3.6 seconds. So 5G is super fast. It's long enough to say, is it done yet? Or maybe, is it done yet? If not now, how about now? It's just super fast, but it isn't completely installed within the United States yet. There's lots of complications, regulations, codes and standards, and red tape that come into play. But that information is for a presentation on another day. Speaking of codes and standards, sometimes they can make things a bit more complicated and difficult to manage. There are many challenges to overcome when working with any fire and life safety project. You have many codes and standards to consider, including the Life Safety Code, NFPA 101, Building Code 5000, the NFPA 72, you've got the IBC, the IFC, and state, local, and even campus-specific regulations to consider when you're putting your fire alarm management project together. Who can possibly keep all these codes and standards straight, right? But it's your job. You have to. The Industrial Revolution kicked off the last century, and now we are at the beginning of the technology and information revolution for this century. Take the cell phone evolution as an example. I remember the old bag phones you could have in your car. I actually had one of those. I thought I was so cool driving down the road with that thing as a young lady out of college. It was like my own personal Batmobile phone. I thought I was so cool. That wasn't until I got my first mobile phone cell phone bill for over $1,300. Wow. There were no unlimited data and phone plans back then, just an outrageous per minute charge. I'd like to say I've curbed my time on the phone, but I'd be lying to you. At any rate, the cell phone continued to evolve. It came to the flip phones, the Blackberries, and the like, to the current day smartphones, where with just a swipe, a click of a button, you can literally connect to anyone, anywhere in the world. Plus, you can look up information on Google, talk to your phone. It actually answers you. It takes pictures, videos, and so much more than just calling and talking. How cool is that? Can you imagine? We would have had to have computers the size of a huge house to carry that kind of computing power in your phone. In the fire alarm industry, we've had an evolution of our own. We used to have the coded systems, the conventional fire alarm panels that gave us the alarm, trouble, or supervisory from a particular building or zone, to the addressable panel that tells us what type of detector and where it was located. Remember when I first talked about emerging technologies? If you were around last century and in the fire alarm world, you may remember the uproar the industry underwent when they introduced the addressable panels. Nobody wanted to trust them, much like the newer signaling communications technologies today. I've served as a technical committee member of NFPA 72, Chapter 24, Emergency Communication Systems since its inception in 2007, to which I still serve on that committee today. Wow, the amount of time we spent as a committee arguing about how reliable certain emerging technology were was nauseating at best. I honestly thought we would never finish that chapter in time to be unveiled in 2010. That's 10 years ago already. Think of all the technological advances we've made in the past 10 years. It's amazing. Technology continues to advance at a very rapid pace. With all this advancement, it creates a real challenge for NFPA. Codes have a set 3-year standard. Right now, we are almost finishing up with the Technical Code Committee meetings for the 2022 edition of NFPA 72. We can't possibly predict what new communication technologies will be developed in the next few years. It makes for a real challenge in the fire and life safety industry, which are built on the main ideas of redundancy, reliability, survivability, and I would like to add hunkability for cybersecurity concerns. An additional challenge is that some local and state agencies don't adopt the codes as soon as they come out. For instance, I think Hawaii just adopted their 2003 code last year. So if I were a person in charge of the project, I would definitely want to design my project with the latest codes, knowing I would be in compliance at the present moment and as much into the future as possible. NFPA 72 is the catalyst for all fire and life safety systems out there today. So what does that mean? It means that this is a book you reference to be code compliant. But it is not enough to refer to this book. It also lists specific UL requirements you need to address. For instance, fire alarm management systems would fall under Chapter 26 for supervising system stations, and it would tell you that your system would have to be UL 864 compliant. That is the relationship between the two. NFPA tells you how the equipment should perform. It's a performance-based code, and UL makes sure that the equipment performs to those specifications. Remember, we were talking about how we don't know what emerging communications technologies would be developed in the future? Here is a reference in the code to where that is covered. Now, I want to caution you. Please note that this code is a minimum code, and as such, you need to meet these requirements with any proposed solution. This means you can use emerging technologies, provided that you can prove equivalency to your local AHJ. For instance, we were working on a project where we wanted to power fire alarm speakers off of Power over Ethernet, often referred to as PoE, mass notification speakers. It was a new technology to the fire alarm industry at the time. This particular project involved a great deal of stakeholders at a meeting in a prominent school district in Colorado. I was at the meeting as a representative from Chapter 24. All the stakeholders were in the room. We did an introductory meeting to explain the concept. I presented as a technical committee member to say there was nowhere in the code it prevented us from using this technology as long as the fire alarm system didn't take the mass notification system down and vice versa. Additionally, we pointed to sections in the code where we met their minimums. After the meeting, we ran a demo/test of the system to offer proof of concept, and we got an emphatic yes, not only from the local AHJ, but all the stakeholders at the meeting. So I guess my advice to you is that you would get the AHJ for your campus involved from the very, very beginning. Nothing is more embarrassing and costly than to pull the AHJ in at the last minute to get approval, only to hear, no, rip that stuff out. This is what you have to have. Also, I find that AHJs are extremely overwhelmed, and anytime you can help point them in the right direction and become their ally or resource of information, they are much more likely to address any concerns. So you can work them out upfront, saving lots of valuable time, effort, and energy. After all, NFPA 72 is kind of like the guide to all things fire alarm in the fire and life safety industry. The better you know it, or key sections, the better you can help the AHJ. Or if you ever get in a bind, you can always touch base with me. Let's look at some legacy and modern fire alarm management technologies. Let's consider the 3 areas where fire alarm monitoring has changed the most from legacy to modern fire alarm management technologies. First are the fire alarm control panels themselves, where the information from the building's detectors reports. Older conventional panels indicate the building where the issue is. However, it only gives you a building or zone, alarm, trouble, or supervisory signal. So what's the problem with this approach? Well, I have a customer that has an airport hangar that covers almost 1.5 acres. If the fire alarm went off and came in as a fire at that hangar, it could take a very long time to get to that fire to put it out if it hasn't engulfed the whole building by the time you find it. It's very limited and detailed information. More modern addressable panels indicate specifically where in the building the issue is and what type of alarm it is. So instead of having an alarm that comes in and says Northeast Hangar Building, the message would read, Northeast Hangar Building, pole station alarm, floor 1, Denise's office. Now the dispatcher knows exactly where to direct the first responders, saving valuable time, money, and resources to quickly address and mitigate the fire. Can you see how far we have come on these panels? It's like going from those old computer screens with dark gray and bright green lettering to today's modern monitors full of color and pizzazz. Next are the methods for communicating alarm information from the panel to a dispatcher. Legacy communications, such as digital communicators, direct wire, and coded signals, can be unreliable, costly, and they're not code compliant. Just as we discussed earlier, more and more of these technologies are fading like that old home phone. However, with evolving fire protection codes, new communications technologies such as Ethernet IP, multipath radio, and cellular are fast and will become even faster when 5G is fully rolled out and complete. They are reliable, code compliant, and cost effective. And there is the alarm monitoring equipment that presents incident information to the dispatcher. In legacy technology, the events come in as coded information, but you had to know what the code meant. Was code 7 a smoke detector going off? Or was it a pull station? You have to look at the cross-reference lists to figure it out before you can make the next move. Now, with more modern, software-driven incident management systems, they provide easy-to-understand event descriptions and can direct maintenance issues to service personnel. For instance, if there is a chemical in the lab that needs to be treated with foam to extinguish the fire, the information can be stored in notes on a screen to be highlighted when reporting the fire to first responders, so you can deploy the right resources to the right location for the right remediation equipment. These feature-rich systems are fast, flexible, and extremely scalable. Let's look at communications technologies. Many multi-building facility managers are currently experiencing reliability problems with older communications signaling technologies, such as telephone lines and direct copper or fiber optic cable. An aging infrastructure can inhibit the facility's ability to reliably monitor their fire alarm systems. This typically results in delayed notification and increased damage from fire and life safety incidents. As an example, we are helping a customer right now that has an aging infrastructure, and every time it rains, their fire alarm control panels go crazy. They are working to upgrade their communications infrastructure to an IP-based system. In recent years, new code-compliant technologies, cellular, Ethernet, and radio, have proven to be much more reliable for transmitting fire alarm signals than legacy technologies. With cellular, it lowers your upfront costs. It requires no wiring. However, it's good to note that there are ongoing monthly fees, just like your cell phones. Ethernet or IP uses existing facility infrastructure. It delivers frequent supervision and is easy to install. And we have the multipath radio. It ensures reliability using multiple paths to get the signal through. It requires no wires and no monthly costs. All of these are excellent options for multi-building facilities and can be used in all types of environments. Let's talk about some changing trends in fire alarm management. Catastrophic events and changes in technology have combined to create new trends in the fire protection industry. For many years, it was about fire detection and suppression, reactive to an incident. The objective was to get people out of the building to save lives and property. That's all your fire alarm had to do, was to get people out of the building. As the years have progressed, our fire alarm control panels and devices have gotten smarter. Recognizing that the fire alarm control panel was being used for more than fire alarm, the NFPA 72 added Chapter 24, Emergency Communication System, in the 2010 edition. Today, our fire alarm panels have become more than just a panel, much like our cell phones are more than just a phone. Now, you may still want to get people out of the building, or depending on the event, you may want to shelter in place. Today, the industry is driven by proactive fire protection. So right now, you're probably thinking, Denise, what the heck does that mean? Well, it means there's awareness of equipment issues in real time that reduces the potential of delayed notification. So for instance, you can get reports that smoke detectors are nearing their end of life and will need to be replaced in 6 months. Therefore, it gives you enough time to plan maintenance or replacement of equipment before it actually fails. By having comprehensive event information, end users can improve the accuracy and speed of response to any given emergency. As an example, perhaps it is a lab area that has chemicals that requires foam to extinguish the fire as opposed to a steady stream of water. This information can be highlighted in the dispatcher's notes when this event comes up on their dashboard to send responders to the exact location of the fire. You get the right personnel to the right location with the right equipment. And there is modern monitoring and incident management software specifically designed for multi-building facilities where monitoring may only be one of many responsibilities of dispatch personnel. Most dispatchers have a multitude of responsibilities and have multiple screens in front of them. Imagine how hard it would be for that dispatcher to have 2, 3, or more fire alarm control panel screens to view. Driven by state-of-the-art software, today's monitoring and dispatch systems provide a wide array of features and functionality to prevent operator overload, improved accuracy, provided increased situational awareness, and enable proactive risk mitigation, including sending only fire alarms to the dispatcher and sending troubles and supervisory to the maintenance personnel so that they can take care of that. There's graphical maps showing detector locations. Why is that important? Because when the fire marshals come in and they want to see how it's progressed, you can see it on the screens. There's libraries of customizable icons, sounds, and colors to enhance dispatcher accuracy. For instance, if it's just a regular alarm, it will go from yellow to red. Imagine sitting in a dispatch area and seeing the same monitors every day and hearing the same tones all the time. So how do you get their attention? Well, you can change the tones. As an example, my husband does armed security for the federal government. So if he's calling me during business hours, it is usually really important. His ringtone is programmed differently in my phone. So when I hear that tone, I know it's important and I should pay attention. The same is true for a dispatcher. There's also audit trails and historical data that facilitate trend identification and analysis. These are great to get reports at any time and help isolate potential issues with equipment. You know, like when every Friday night you get a fire alarm from the Chi Omega sorority house, you see a trend, you investigate, and realize Friday nights are movie nights and they have a tendency to burn the popcorn. A modern alarm management software should be flexible, compatible with a wide variety of manufacturers' fire alarm control panels, easy to use, and be code compliant. Situational awareness. Situational awareness almost seems like it has become an overused hashtag at times. Everyone says it, but do you really know what it means? Let's take an example. Imagine if you were in charge of a multi-building campus, but you had no way of connecting your fire alarm panels together. A fire on the North Campus in a building that is used primarily as a lecture hall and a lab for chemistry and biology is on fire. Right next to that particular building is a series of residence halls in close proximity to them. However, you have no way of seeing if those flames from that fire started a second fire in a residence hall or someone was burning pizza in the microwave again, because that is a completely separate and independent building with a totally different manufacturer's fire alarm control panel. How can you know what is even going on? This situation is not uncommon in multi-building facilities that have been built, renovated, and expanded over a series of perhaps hundreds of years. And you are in charge of a hodgepodge of fire alarm panels. It would be tempting to just have all one brand of fire alarm control panel, but that can be costly to rip them all out. To increase situational awareness, wouldn't it be nice to have all 200 or more of your building's existing fire alarm control panels coming into a single view? And if that alarm came in from the north end of campus with a chemical fire, to have notes on the dispatch screen that said to evacuate the residence halls now? You are now in control. Or if there was a fire signal that came in from a smoke smoke detector at the Chi Omega sorority on Friday night, you could send service personnel to investigate to see if it was a real fire or if they burned the microwave popcorn again. Plus, your dispatcher would have all the information coming in consistently within a specified, easy-to-read screen. They would only have to know one screen and not 2, 3, 4, or more, instead of having all of those screens to review. Again, it increases your speed to respond to any given situation with the right equipment, to the right location, with the right personnel, each time, every time. Now, this is where I really like to get into what an ideal multi-building facility fire protection system would look like. So I'm going to ask you to get just a little comfortable and use your imagination, and let's dream a little. What would it entail? Well, it would be a code-compliant system which provides detailed information in one unified view from any mix of fire alarm control panel brands, so I could see events as they unfold. I like to see, like, I'm the captain on the Starship Enterprise, and I can see everything that's happening on my campus. It would provide easy, cost-effective transitioning from my existing technologies to a new communication signaling technology by combining them both in one system. It would include feature-rich, configurable alarm management software to meet my specific facility requirements. It would provide a centralized view of system activity for corporate risk managers to monitor the overall health of the fire protection system and minimize fire and life safety incidents. And since we're dreaming, we could have all of this without replacing most of my existing fire protection infrastructure for a very cost-effective solution. Wouldn't that be the perfect solution? So you want the solution, but where would you begin? Well, you need to evaluate your current campus systems. Are they currently being monitored? If they are, great. If they're not, how can you monitor them? Determine if you're satisfied with the information you receive from them. You have to figure out what works and what doesn't work. Are you getting your information quickly as you want, or is there somewhat of a delay? Or are you having problems when, say, there's a storm going on and you can't get that information? One of the key things to do is make a list of the manufacturer model of your fire alarm systems and determine which you would continue to use. Now, let's face it, if you have lots of buildings over a long period of time, there's going to be some older panels that are going to have to be upgraded. Or are they doing a job that's good where they're at, and that's the best fit for your particular solution? What communication technology or technologies are used to transmit signals? Are you using the telephone lines? Are you using copper wires? Is your existing infrastructure viable for long term? And if not, how long? Are you under restrictions? You need to do it within 3 years to transition? Do you have it under 1? What is it that's important for your campus? Is there Ethernet infrastructure available, or do you need a wireless system? That requires talking with your IT department and having frank conversations with them. Does your team know enough about where on campus alarm troubles and supervisory happens? That helps you decide, where do I need to send my personnel? Where do I need to allocate those particular resources? Do you need to improve overall situational awareness? Do you want to know what's going on with every single one of those fire alarm panels and having it called all into one central location? Only you can answer that of what's best for your campus. I know I would want it. I know starting this process can be overwhelming at best, but it is a necessary step in moving forward to that ideal solution of having all your fire alarm panels coming into a single view so you can take control of your campus. So you're thinking, Denise, yep, got my stuff, but what am I going to do? Because I don't know if I can afford to transition all at the same time. Well, this is what I'm going to tell you. These are just some of the best practices for transitioning. First, you're going to go back to your campus evaluation and inventory. And again, you're going to have to take a hard look at what is and what is not currently working well for your particular campus. This is my favorite. Determine budget availability. There's a cost associated with this, so you need to figure out what is it going to take in order for me to move from where I'm at today to newer technologies for tomorrow. Then you're going to have to say, what kind of personnel do I need to make this happen? And again, we're going to talk about that time frame for transition. We've worked with customers that were under the deadline and had to transition within a 6-month time frame. And getting the budget and the stakeholders and everyone together, that sometimes creates major issues. But we got it done. You need to include your stakeholders. Remember when I was telling you about having that meeting with all the stakeholders at hand? Fire and life safety managers, it would be IT, your EHSs, the AHJ, definitely security, police, anybody that you think could be an active stakeholder here. I also like to think that sometimes you could rely on some alumni from your university to come into this meeting if they have any type of expertise. And maybe I might add some deep pockets. Select a dedicated person to oversee the project. There's nothing more frustrating than trying to herd a bunch of cats together and have 2 or 3 cat herders. Put it into one. Have one dedicated person to oversee the project that's responsible from installation to final inspection. Determine the order of migration across your buildings. This is probably the most critical one, next to getting all your stakeholders together, next to getting your budget together, and having that dedicated person. Decide what's best for your campus. Maybe right now we don't have anybody in the dorms or the labs or the classrooms. Maybe start with the dorms. Maybe start with the classrooms. Maybe it's the stadiums. How about the library? There's so many different ways you can do this. Maybe you have some remote campuses that you deal with. And you're going to have to figure out, maybe it would be easier to start at the head end and then add in your remotes first. I don't know what's best for you, but that's something that you're going to ask whoever you're working with. While there are many things to consider when transitioning to newer signaling communications technologies, these are just the top best practices to put into place for you. What does the future hold? Wow, I wish I knew, but I can tell you, we are in the wild, wild west of technology and changes. Imagine how different even the past few months have been, with most people working and studying remotely from home. Who would have thought at the beginning of this year that we'd all be here today? One of the biggest changes coming in the 2022 edition of NFPA 72 is the addition of a new chapter, Chapter 11 on cybersecurity. I've served as the Cybersecurity Task Group Chair for Chapter 24 and serve on the task group for Chapter 11. Right now, at the time of this webinar, it is still in the final draft stages and anything can happen. But at this point, it is on track to become one of the biggest changes to NFPA 72. I hope you'll join me in the fall when I present changes to this particular NFPA 72 and discuss cybersecurity. Details will be sent to you as the date gets closer. I'd like to thank APA and CCFF for allowing me the honor to share this webinar today with you. Caltrain has provided fire alarm and life safety event management solutions for over 50 years. With interfaces to over 95% of the fire alarm control panels, backwards compatibility, and the ability to have multiple communications technologies bring all of your fire alarm control panels into a single view, Caltrain can help you find a solution that's best for your campus. Caltrain's engineering team continuously develops new ways to harness technology to enable our customers to improve their response to fire and life safety events. These are just 3 of the new solutions that provide improved situational awareness, consistent reporting, and faster, more accurate signaling, all improving the speed and accuracy of response that is so critical today. We have some questions.
We do, and first of all, Denise, this is Kathy, everyone, and Denise, thank you so much for your time today. It was a great presentation, and we have quite a few good questions. The first one, can I use this system even if my facility is monitored by an off-site commercial monitoring company?
Wow, that's a great question, Kathy. And thank you. Yes, with Caltrain, you actually get two major advantages besides those described in my presentation. Our system can aggregate all the signals into one telephone line to the central station and save on costs, and will provide overall situational awareness for on-campus managers who want to know what is happening throughout their campus.
Okay. Next one. Does head-end equipment need to meet UL 864? And if so, does Caltrain satisfy those requirements?
Again, when I was talking about NFPA 72, how it sets everything up, it does require it in Chapter 26. And yes, Caltrain does have a UL 864 listed head end.
Okay. There's quite a few, so I'll go as quickly as I can. What companies do you recommend to service fire alarm systems if we are unhappy with our current company?
If they're not happy with their current company as far as servicing fire, is it for fire panels? I guess I would need to know a little more. Are you looking for the management of the head end equipment, or are you looking for the actual fire control panels? Can you just read that again one more time, Kathy?
Sure. What companies do you recommend to service fire alarm systems if we're unhappy with our current company?
Wow, that depends on where you're at. If you're not happy with your current fire alarm servicing company, I would recommend that you go out. I would have to know a little bit more about that particular one in general.
Well, and we'll give you the questions if you need to communicate offline afterward, too.
Okay. I'd be happy to do that.
Next one, are existing telephone lines as primary signaling grandfathered?
Well, I'll have to look in further into that particular one to give an accurate response, if you can send that one to me.
Okay. The other is, we need to transition over a 3-year period. Can you combine our telephone lines with the IP system so that all of it gets into a single view during that time?
That's a great question too, one I can actually answer. One of Caltrain system's primary advantages is the ability to combine multiple types of signaling communications in one system. So it makes it easier to migrate even if you don't have the funding to do it all at once. So we can take the telephone lines, we can do any type of legacy technologies, but we also can do IP, radio, and cellular all into one system.
Okay. What are some of the pros and cons of using IP versus RF communication infrastructure?
Wow, that's a great question. When you come to, there's a lot of differences between IP and radio. So the first thing you need to verify is that if you have enough bandwidth, if you have a strong infrastructure for your IP signaling. Not all terrains will work with IP technologies. Sometimes you have to do a combination with the radio as well. So for instance, we have a particular customer and they have some outlying buildings, but it's too expensive to actually blast the stones to get the wires that they need. So they're doing a combination of radio versus IP. They're both extremely fast in reporting. So I think that it really would come down to what is it specifically that would be best for that particular site. I would have to know a little more about it, but there are some distinct differences, and especially with IP, do you want to take control or work with you? Development, sometimes operations and IT don't get along so well, so it's really kind of a political more than anything else.
Okay. Next one. On our campus, we have a few upgrade days every year when the data network is taken down. How do you keep your system operational during these upgrade days?
I'm sorry, I only got part of that. Could you repeat that? I'm sorry, I just got part of that.
Sure. On a particular campus, they have upgrade days every year, and the data network is taken down. During that time, will your system remain operational, or how do you keep it operational during the upgrade days?
There's a couple different ways that you can address that, but I would have to address that specifically with that particular campus because it's going to be different for each and every site. And it's about when you take when you're going to do upgrades on particular days, are you going to do certain buildings versus are you going to do the whole campus? Do you have phased in approaches? Do you not have phased in approaches? How are we going to attempt that? So I may have to do a direct response to that one.
Okay. With the use of mesh radios or cellular transmitters, the signal is sent intermittently or immediately outside of the protected premise. These technologies are required to also maintain secondary power sources equal to the fire alarm system in order to ensure transmission. How do these secondary power requirements affect the power backup requirement of the building infrastructure that the IP communicator would be utilizing? It's a long one.
It is a long one. I may have to look at that one and get a response back directly to them.
Okay.
But you're still going to have to follow NFPA 72 guidelines for that.
Okay.
Very backup.
I know we only have 9 minutes left too, and there's quite a few questions. Code requires, upon activation of a fire alarm, the fire department to be notified. Should we send maintenance because of the history of burnt popcorn to investigate? If it was a real fire, then the delay in department notification could cost lives.
I was using that as an example because you know that it's historically done that way. Just as the audit trail, and it historically said every time we had a fire truck coming there and it was a burnt popcorn, I was using that just as an example. Of course, you would have your message go on there, but you could call the building immediately and say, hey, what's going on? Is there a real fire?
Okay. We have buildings spread out throughout our county. Each building is monitored separately by central station. Will it make sense to aggregate them? You might have answered that.
Yes, I did.
Yeah. What alarm monitoring software companies are on the leading edge?
I think that they're talking about the monitoring that they're doing in central monitoring. Is that would?
Okay.
I don't want to single one company out because I don't support just one. I just don't know.
And there's some that one question about the local rep, but those are things that you can answer offline.
Yes.
Here's one. What dual path signaling transceivers do you offer?
Well, that's a good question. Caltrain offers our new IP transceiver with cellular backup option, and we have a mesh radio with an IP backup option as well.
Okay. Okay, here's another great presentation. Thank you. Does this Caltrain solution only address monitoring, or can it be used to send out messages from a central location to all buildings on campus, similar to mass notification?
Wow, you're getting into that's really good. The shorter answer is yes, we can do it. The long answer is there's a lot more involved to that.
Okay. And I might be,
I wanted to go back and address the one about the IP system on upgrade days. It's only if the IP system is on a private VPN. So I'm not sure if that answers it just correctly, but or gives them what they need, but I'll make sure that I answer that if you give me the questions, I'll be more than happy to answer that.
All right, and we will. We'll give everyone the questions. There are another few questions on certificates, and just contact Billy if you're looking for an APA-related certificate, or contact me, Kathy Tabor, if you're looking for Campus Fire Safety ICC CEUs. As Billy mentioned, we will have everything posted online, and we'll let everyone know when the presentation or the recording of the presentation is posted. Denise will get a copy of everyone's questions. And I'll just turn it back to you, Denise, to say goodbye, and Billy, and thank everyone for attending.
Thank you, everyone, for attending. Thank you for your listening and your great questions. I'll try to get any of those that I didn't answer fully directed to you. If there's anything that Caltrain can do that we can help you in the future, I'd be more than happy to connect with you and take care of that. So until we can see each other again in person, please stay safe, wash your hands, and hang in there.
Denise, this is on behalf of APA. I would like to thank you very much for a very informative webinar. And to those who took time out of your schedule today, thank you so much. Be safe, be healthy. Until we see each other again or talk for our next webinar, have a great rest of your week. Bye-bye now.
Bye, everyone. Thanks.
Thank you, everyone.